That's your 5-inch high pressure steam valve coming from the system that's there, the high pressure steam. Comes around your steam meters right here. Comes off to here. Here's your hot trap for the high pressure steam for this header. Going through your two PRVs, which reduce it down to low pressure steam. One's a low and one's a higher pressure as far as whatever that goes.
1/3, 2/3.
1/3, 2/3, good enough.
Is that what it is? The smaller one is 1/3?
1/3, the other one's 2/3.
Okay. Do they both function at the same time? Or?
I think that one functions at a lower pressure, and then when it needs the other one kicks on at a higher pressure.
Okay.
That's what it is. This goes down to that 10-inch header. These are like servicing valves you got back here for these PRVs. Comes into the big 10-inch header, which is there's the low pressure condensate right here. For this header right here. Then you got your 1/3, 2/3 for your heating system right here, which are these two control valves up here. And then that comes back to this other header and then feeds back across to your two heat exchangers. This is a bypasser, just in case you need a bypass valve. If the doors go down, you can always bypass it and run it. And that goes across the top of these other valves and goes into the heat exchangers for your heating water. This other line right here, Chris, this other 8-inch here, goes down and feeds, for the bypass, it also goes down and feeds that traffic into there and picks up the two domestic water heat exchangers. Right. Those two 3-inch valves are there, valves. And the relief up there is right there.
Now let's go down and feed the water.
And then that's going down to the domestic water heat exchangers and the traps for them, to the condensate, and then back to the condensate receiver. Here's the traps for your two hot water heating for your building system. Traps back there, both of those.
And so far, I haven't heard any problem with that trap down below on the water heater clanking or holding any condensate. We were concerned about that being lower than the condensate line without a vacuum.
It was, but I've never seen a problem with it unless it's way too high for low pressure. I mean, it always pushes it out.
Okay.
Well, that's pretty much all your steam system, other than coming back to your trap and doing your condensate receiver. And your condensate receiver pumps up these two, and then back to the 4-inch line over here, which either goes back to Regenstein or back into the steam system. It's actually that valve over there that you see behind the screen.
Right. Okay.
So that's pretty much all the steam you have in here, other than just what's in the building.
And this, well, this is plumbing, but you got the two recirc pumps over here, and they're designed to be used just one at a time, right?
Yeah, that's how I understand it.
Okay. Go ahead.
These are your chill water valve or hot water valves. These are your ones you got to change every winter and summer. Right now they're open for heating. This is the one. Here's the other. There's one right back here. And these work in conjunction with, you can't see the handles on the back side. I'll let your head there with the trap.
Right.
These have to work in conjunction with those two chill water valves.
Right.
They should really all be open at the same time and shut the other one, whatever you're doing. And that just goes back to these two lines here. And then they're going into the air troll, through the heat exchangers, back out into the system.
Okay.
The chill water runs through the building the same way and runs. Two isolation valves for this whole building are 103 and 104. If you have to shut this whole building off for some reason, obviously you want to shut the pumps off first. You just shut this and isolate the whole building off here. And the isolation valves for the pumps, I didn't change. I didn't put a tag on those for the pumps. You can see what you got down here. These are the isolation valves for the center handler. 102 and 101, and then all the controls and everything are just up to whatever you need here.
Why don't you explain a little bit about the bypass on this pump and supply for this air handler?
Pretty much what you have here is here's your supply. You can kind of see the supply from the other side. It comes down through here, comes through the pump, goes into the air handler. There's a split coil in here, so there's two separate coils in here. It comes back, there's circuit setters here that are set, and you come back through here, it goes back to the return through the control valve. If the control valve shuts, if the control valve is satisfied and you don't want any more water, that shuts, and then the water comes back through this way through a check valve and back through the pump and just recirculates for freeze protection. So that's pretty much all that's here. You got valves for shutting off each one of the coils if you got a problem with the coil or something. But you should always have, the pump should always be running.
Okay. Now this is a water system, not a glycol system.
Correct.
And this air handler here is a 100% OA
100%,
air handler.
Correct.
So what do we do about freeze protection here? What do we have on, tell us about freeze protection.
The pump right here. That pump is always got to be in operation. I think you have, now the thing I don't know about, I know you got an outside air damper in there. So there should be something that I guess if the pump goes down or something, it should be set up where it should shut. It should
That's
shut
how the
down.
controls will be set. Now what's going to happen is that when there's a freeze stat on the coil, and it's serpentined on the coil, and when the temperature reaches a point on the coil that it's below freezing, what'll happen is the dampers will shut down and you'll go into an alarm mode, and Johnson will identify that this air handler is off. You're in a low temperature mode in the air handler and you need to do something.
Now you said there's a serpentine coil that senses when the temperature on the coil is below freezing.
Right.
Isn't that going to be the case on any day where the temperature is below 32?
It's on the leaving side.
It's on the leaving side. Okay, well that's important to understand, because
Sorry.
if it's on the supply side, it's going to be that way most of the winter,
Right.
which means it's to be shut down. Okay, so it's on the leaving side. So if there's some problem with this pump not circulating warm water, and that gets below 30, well, actually should be set a little bit higher than 32, I would hope, because you would have already frozen the coil by then, right?
These things come preset from the free stats are like preset, and I think, I don't know, do you know what they're set for? Are they set for 35 typically or 40?
Hopefully they're set a little bit above 32 so that you shut it down before the coil freezes up. And you say that's is that a power actuated damper?
I think they're electric. Yeah, I'm not
Okay.
sure.
Yes, it is. It's
Okay, say that again.
They're electric dampers that they're probably set up for the freeze protection of it.
Okay, where is the control? Where would the control be for that temperature on that sensor?
Those are Johnson control clutches.
He's going to have one control box in each building for the building. It'll be located in the mechanical room. This is the control panel. Everything is set in here for the building. There'll be one exactly like this in B, and then the main one will be in A, which will also have the computer in it, and then that will be going all the way back to, that'll be the computer interface to the library, and that's going to be interfaced.
Okay, so this unit here will have the control, the free stat control for this air handler behind us.
Yes.
Okay. Although,
Jim would just point out one of these might be, one of these controls might be the freeze stat.
Freeze stat, that's
One of these might be for a filter. One of these controls might be for a filter. What, 30 filters?
so what does that do? Is that shut down if it's?
I don't know if it shuts down, or it's maybe going to give you an alarm or something.
Alarm.
I'm not sure what it'll give you.
Because we had some pretty dirty filters that we just pulled out of here not too long, a week or so ago,
Out of this
from all the construction and everything outside.
I'm not sure how it's controlled, but I know these are the control assemblies that are on here.
So it's basically these two. And the fan runs a constant speed. It's not a variable speed fan.
Nope. Always on, always the same thing. It's 24/7. It's just on, always.
Sure.
Just fresh air making. Okay.
You might run into a problem with your filters right now anyway, because it's full outside air or whatever, and with all the construction you'll have more.
Well, I was just telling Dan that we've already replaced the filters because they were really dirty, and actually the dirt was getting through into the coil because of all the construction outside and being sucked into that grill.
Good point.
Go ahead.
Okay, this is your gram drive, which is your like a rheostat basically for your pumps, and it's set off automatically. It's set off of, there's a pressure differential switch on the end of the mains all the way in the crawl space at the end of the mains. It's down near the lobby where you walk in. There's a little switch there that senses all the pressure, and it takes off from the whole building, and it runs the pumps at the speed they need to run. So if you're needing more heat and fluid, that's what's going to drive these pumps higher or lower. I'm sure there's a manual switch on them. I don't know what else there is.
And currently we're running heat, and we're running about 50% of this one pump here.
And that's just the one pump. You have to manually switch that over to the other pump or whatever.
So tell me about these pumps. These are redundant pumps? You only run one at...
You only go on one at a time. It's just like a backup if you need the other one.
Okay, and then they are variable speed or variable frequency,
Well,
whatever you call them?
Mostly from this.
Right, the drive what happens is that you set the point is set on you set the point on here off of the end of the line static pressure sensor. That senses the line, it comes into here, and then it maintains a level. Now, it's maintaining a level so that all units can always get pumped. As more units turn on, the pressure will start to decrease, and then the pump will increase, and you'll sense it'll go up and down to maintain this. So in the middle of winter time, you should be up very high, and you know, real
in the middle of
mild
summer.
days should be very little. So
Now, which is why I'm asking, this is a mild day today, yet we're running 50% on the pump. When we had mild days and weren't running air conditioning because it was cool, we were down to 30%. Why would we be so much higher here on the heating side of it than the cooling side? No idea. Okay.
all I can tell you is that you've got a load. You know, someplace you're asking for some water. You've got some rooms that are asking for water right now.
Whereas with the cool days, we weren't asking for a whole lot of chilled water.
It could be that what happens is that if the students leave, and this is just if they leave in the morning early, and the night's been cool, and they got this thing going, if they
they don't do that. They don't leave their units on. They turn them off.
Okay, I'm sorry I even mentioned that.
In the crawl space, there's a cabinet unit heater on the north wall right next to the air handling unit. This unit needs to run only during the heating season and needs to be valved off during the cooling season. And those are the valves right there. But because the room probably will stay warm enough, this should stay off at all times. That unit is controlled by the thermostat on the north wall. Right there. So it's been shut all the way down, and we need to valve that off.
Just on this valve list.
In the fan unit or fan room, there's a shut off for a rental radiator in the northeast celosea in the ceiling.
Now this is for the interior courtyard. Is that what
Interior courtyard, northeast celosea.
I don't know what northeast celosea is.
That was off, I assume.
Yes, these are off right at the moment.
Okay.
Because I gotta get.
Okay, go ahead.
There's a ball valve and a circuit setter on these, which are your shut-offs. I did not valve tag those because they're just for the unit, whatever they are, right next to the unit.
Right.
So I think that's the return sensor for your ductwork.
Yes.
And your condensate drain over there, and all this other stuff is controlled thermostatically. I guess that's the thermostat for that ductwork sensor is the return.
Right.
And that's, I think, all 9 of these FanCo units in this building are all controlled like this. Thermostat on the unit, duct sensor in here. Don't know what else there is.
You are correct there.
And chill water or hand or hot water. So it's got the drain off every one of those and a control valve for them. These are all 100%.
I assume this was spec that way, but in order for me to, let's say, get into this line, to rod it or whatever, I have to break the line. It's all solder. There's no unions.
There was no unions, there was no 90s, there was no clean outs, there was nothing.
You're absolutely right. That's the problem.
These 2 valves and some circuit setters up here for your heating water supply, which are the 2 cabinet unit heaters for the 1st and the 4th floor on the number 3 stairwell. Shut these off for summer operation, otherwise you're going to sweat. And then there's a couple in this room over here also, the same thing. You want to come over here.
Could you talk a little bit about these?
Why don't you go to here for these pick up, 2 of these pick up the rental at the end of the hallway, and the other 2, one going this way, one going this way, pick up the rental in the big northeast tower, the 1st and the 3rd floor. So these are ones you'd want to shut off for summer. These 4, those 2, and then the other ones I showed you, then some more down in the basement of the tunnel. So that's...
Okay, go ahead.
Is that in the 3 study rooms,
2nd, 2 and 3 and 4.
yeah,
2, 3, and 4, yes.
2, 3, and 4, these ducts rise up in the wall and have an electric heater on them coming off the primary air. And so if there's a call for additional heat, those heaters will go on and provide additional heat to those study rooms only.
This is exactly what we need for the rest of the units. Clerk out of the closet, trying to be warm in there.
So those study rooms receive only makeup air from the main makeup air duct right here. And if that's too chilly in the wintertime, they have an electric resistance supplementary heater.
Yes.
In the summertime, they only receive whatever tempered makeup air is coming from the makeup air unit. There's no additional air conditioning.
Correct.
And the switches on the wall are the main power source
Yeah.
to shut those units off, and then there's an additional shut off.
I think there's more, because I think
on
there's
the
6 in here. I'm not sure.
Yes, there are
More,
6
three
because it's
rows.
second, third, and fourth floor, east and west.
There's more switches
So there's more
here.
switches underneath here.
What's going to, do they have a sales switch on these or something?
Valves and all that stuff up around the rental, so everything is drained. You get a drain from the 4th floor, you come all the way down to the basement to drain everything. Every one of the rides just have a drain on it.
Do you know if the existing pipe situation up there is the way it's going to be? Some of the piping is
The
uncovered?
rental?
Yeah.
Yes, as far as I know, it's all uncovered. It's going to be painted. And some discussion plates or something. That's the only little thing on the end of the hallways. That's the only thing we know.
With some sort of support, though. We're looking at.
We are not doing that. We talked to Primera and let them, somebody, whoever ordered it, or VOA or somebody, right?
We've you know,
Address that concern.
we've only stated that you know, we've installed it per the manufacturer's recommendations and per the direction given, and you know,
For slight fee, that means.
we'd ask them, you know, we don't even know, whatever I put in there, I'm sort of worried about how to design it, you know, that it would be holding up right, what do we design it for, you know.
So you got your outside switches for power on, thermostat control right here. There's an aquastat. I'm not sure that it's going to sense hot water or chill water basically. Your control valve is right here with a little bypass switch, which you can barely see there. It's a little levered. If you have to, you can open up and it opens the valve up. Now these are shut-off valves in here. Vent on the coil. What else to say?
So that's the vent on the coil there.
No condition. We did it for, I don't know, I just went through the testing pretty much.
So what goes wrong in this unit that needs to be serviced?
I have no idea.
Lower
Lower.
switch, the valve down there.
Possibly control valve ahead,
So
maybe.
you've got the 2 red handles there are the shut-offs to
Filters
shut off the hot.
changed between, before we moved in, stuff like that.
Supposed to get a list.
Yeah.